This is the George Burke family of Atlanta, Georgia. Wife Jean, daughter Annie, and son Alan. Dad has just taken them for 2 weeks of island hopping in the Bahamas, and now they're heading home. Up to this point, the only distraction for George is the constant chattering and bickering of young Alan and Annie as they become bored and restless.
How much longer, Dad? I'm getting hungry.
Hey, Dad, are we gonna stop in Dublin?
Figure we'll head right on into Atlanta. It's not that far, and we'll be home a lot sooner.
Why didn't we stop to get something to eat?
Wish we'd refueled along the way.
What's happening?
We're out of gas, stupid.
There should have been another 30 minutes in that tank. I wonder how much is in this one. I'd better notify approach. Atlanta approach, this is Cessna 87 Mike Sierra. I need to declare a minimum fuel advisory.
87 Mike Sierra. How much fuel do you have in time?
I think I have about 10 minutes.
Okay, you're cleared direct McCollum. Wind out of 350 at 20, gusting 28.
I told you. Always pushing the limit.
Apparently that guy didn't top those tanks off when I refueled in West Palm. I should have refueled in Dublin.
In this fictitious vignette, George Burke foolishly jeopardized the lives of his entire family. And statistics suggest that this is not uncommon. Many factors lead to incidents and accidents, but a large percentage of them are a result of pilot decision-making or a lack of pilot knowledge. Don't make a mistake like the one George Burke made. Always remember, airplane fuel is absolutely, positively indispensable. There's no way to fly an airplane without fuel. And to fly one safely, you've got to know all there is to know about that indispensable liquid. As we've seen, a lack of proper fuel planning can be disastrous. But carrying ample fuel can buy you options. In other words, with recommended fuel reserves, you're less likely to make rushed and even possibly dangerous decisions. In the next few minutes, we're going to examine the basics of fuel and fuel usage, and then apply this knowledge to a checkout and flight in an aircraft that's just a little more complex than your basic Piper, Cessna, or Beechcraft. But no matter what kind of plane you're flying, fuel awareness is essential to safe operation. Aviation gasoline, or avgas, is not unlike the fuel we use in our cars, but there are differences. Airplane fuel has a higher octane rating, so it's less likely to cause knocking in high compression engines. It's designed to last in your tanks and not decompose over time. And avgas contains a small amount of lead to cool the engine valves and prevent engine knocking or pre-ignition. Jet fuel is different. Similar to kerosene, it burns at much higher temperatures and can ruin an engine if it's accidentally put into an engine designed to run on avgas. To avoid any mix-ups in dispensing, remember that jet fuel is clear, while avgas is colored. Some airplanes have special restrictor rings that will not accept jet fuel nozzles, but don't count on technology to ensure proper fueling. Fueling is usually uncomplicated, but once in a while problems occur and airplanes are fueled incorrectly. That's why pilots should be on hand to supervise the fueling process. If that's not possible, be sure to cross-check the fuel ticket for type and amount, in addition to sampling the fuel in your airplane. Avgas comes in different colors depending on the octane level. Here's a quick rundown. Blue is 100 octane, low lead, and this is the most common. Green is 100 octane, and it has a lot more lead than blue. Red is 80 octane. Here's an important point. Jet fuel, when mixed with any of the colored avgas fuels, is designed to wash out the color, but that depends on concentration. Another good test for jet fuel contamination is to put a drop of fuel on plain bond paper. Jet fuel will dry with a visible ring. Avgas leaves no ring. But of course, the best thing is to supervise the fueling. That way you know what's going into the tanks. It's also a good idea to check the fuel ticket for type and quantity. George supervised the fueling, so why was he underfueled? A unique characteristic of George's 210 is that the tanks are long and flat, and care must be taken to fill them completely. The lineman should have fueled one wing, then the other, back and forth about 3 times. This allows the plane to maintain equilibrium during the fueling process, so each tank is eventually filled to capacity. It's a trick of the trade for 210s. Almost every aircraft has its own unique characteristics. It is the pilot's responsibility to be aware of these possible pitfalls. During your pre-flight, you should automatically check for full tanks and then sample the fuel sumps. In this sample, pay close attention to the color of the fuel and for any water and particulate matter that can cause performance problems. Let's look at some basics here. Fuel is pumped or gravity fed from the fuel tanks to the engine. There it's mixed with air in a carburetor or injected directly into the cylinders where it's ignited by spark plugs. As air moves through a carburetor, its temperature drops, and if conditions are right, water vapor within the air can condense and form ice that restricts the flow. Most carbureted aircraft are equipped with pilot-operated controls that route heated air to the carburetor to melt the ice and to keep it from reforming. Many aircraft engines are fuel-injected. Here, the fuel is injected directly into the cylinders where it is mixed with air and ignited. Fuel-injected engines can't develop carburetor ice, but can, under certain circumstances, develop ice restrictions in their air induction path. Fuel cannot burn without oxygen, and in order to achieve optimum efficiency, fuel and air must be mixed in the right proportion. The amount of oxygen available for combustion is determined by air density, which is a function of altitude, temperature, and humidity. So for any throttle setting, altitude, temperature combination, there will be a given amount of oxygen. Using the mixture control, pilots adjust the amount of fuel to achieve the proper air-fuel ratio. Reducing the fuel flow is called leaning the mixture. Increasing the fuel flow is called enriching the mixture. Now, if you're wondering why leaning is so important, here's the answer. All performance, range, and endurance figures for your airplane are based on a properly leaned engine flying in optimum conditions. So the book can't tell you how fast you'll fly, how far, or how long unless you lean. And one more thing. Many pilots think that leaning is only for high altitudes. The truth is, leaning is appropriate at any altitude as long as you're at cruise power or less than 75% power. If leaning is so important, you'd think it would be one of the first things you learn in flight training. Unfortunately, that's not the case. Most early training flights are short and the power is adjusted frequently. Fuel consumption isn't an issue when departing with full tanks for a flight of an hour or less, and it's easier to leave the mixture rich. Many instructors don't teach leaning until the cross-country stage, and some not even then. If students do all of their flying with rich mixtures, they probably won't lean as rated aviators either, and that can spell trouble when they try to get book range and endurance performance. So make leaning a habit on every flight. There are 3 ways to do it, and the airplane's POH will tell you how. On basic airplanes, set cruise power and lean the mixture until the engine runs rough. Then enrich the mixture slightly until the engine smooths out. If you need to climb to a higher cruising altitude, enrich the mixture before adding power. If you are at or above 75% power, and then lean again when you level at your new altitude. Many airplanes are equipped with exhaust gas temperature gauges, or EGTs. Once again, the POH will be your guide in instructing you to lean the mixture until the peak exhaust gas temperature is reached. Usually, the most economical mixture setting is obtained by peaking the EGT and then enriching it by 25 to 75 degrees. Pilots of some turbocharged airplanes lean with a turbine inlet temperature, TIT, gauge. Consult your POH for instructions. One more point about leaning. Operating with carburetor heat will result in a richer mixture because the heated air is less dense than ambient air. Pilots should lean while operating with carburetor heat and richen when carburetor heat is no longer needed. Now that we've reviewed how to lean, we can consult the POH for fuel consumption figures. That way we'll have some idea of our range and endurance. Those pilots who have a lot of experience with one airplane know pretty well what fuel consumption will be. But until you get to know your airplane, we recommend that you add a gallon or two per hour to your fuel consumption estimate. The FAA and Air Safety Foundation also recommend that pilots estimate how much fuel their airplane will take at each fuel stop. Comparing this estimate to what actually goes into the tank is an excellent way to quickly develop fuel sense. Many pilots make a mental game out of this, seeing how close the fuel truck delivery is to their prediction. In flight, the FAA and Air Safety Foundation recommend that you recalculate range and endurance hourly. By doing this, you'll always know how far you can go on your remaining fuel. Of course, this will only be accurate if you know how much fuel you're burning. Many fuel-injected aircraft have a fuel flow gauge as part of the standard instrumentation, but if your plane doesn't, then you will only know the burn rate through experience and calculations. By recalculating range and endurance hourly, you are monitoring the burn rate and can make adjustments to your flight plan for safety's sake. FAA regulations require a minimum fuel reserve for all operations, but we recommend a more conservative approach. Pilots should never land with less than an hour of reserve fuel in their tanks. The cardinal rule that George broke was that he assumed that his tanks were full and didn't plan a fuel stop in Dublin. This assumption could have cost him an off-airport landing, or worse. George didn't know his plane very well, and he wasn't aware that he had less than full tanks. But he could have compensated for this situation by conservatively estimating fuel in the tanks. With a handheld GPS, such as this one, you can quickly estimate your fuel usage on an hourly basis. Here is a preliminary view for George's flight. In a calm air situation, the flight that George planned is possible with the recommended margin of safety. However, in the real world, winds, air traffic delays, and weather are big issues. Given headwinds and tailwinds, the speed that George flies can change from what is shown. This is a good tool, but it doesn't calculate fuel consumption. That's up to the pilot. Had he known how much fuel he was carrying and the rate at which it was being consumed, George could have checked his fuel situation hourly. This would have kept him up to speed on the fuel remaining so that he could have planned accordingly. Some advanced GPS fuel flow systems can automatically calculate fuel consumption, fuel to destination, and fuel remaining in tanks. However, even with this high-powered equipment, the pilot should be maintaining his own calculations to serve as backup. In most airplanes, the fuel is stored in wing tanks. To maintain lateral balance, which makes holding your heading easier, drain the tanks in equal increments. For example, after takeoff, fly 1 hour on the right wing, then 2 hours on the left wing to keep the weight equally balanced. Using these hourly increments makes it easier to remember the time to switch tanks. Many pilots mount a timer in plain view to remind them to switch tanks. Many airplanes are equipped with auxiliary fuel tanks that don't always feed the engine directly. Fuel from the aux tanks is transferred to the main tanks and then fed to the engine. An electrical failure could prevent fuel transfer, so prudent pilots transfer fuel as soon as there's room for it in the main tanks. Refer to your manual on how and when to transfer fuel to the mains. Besides the burn rate of your airplane fuel, you must also consider that fuel has weight, approximately 6 pounds per gallon. And when your tanks are full, you may not have the options that you would have when they're not full. Many general aviation airplanes cannot safely carry a full complement of passengers and baggage with full tanks. Pilots must decide what to limit in order to comply with weight and balance limitations. Ed Simpson has just bought a new airplane. It's a Bonanza A36 with tip tanks, a real step up from anything he's ever owned or flown before. Today, he's meeting with his instructor, Charlie Duncan, for his initial review and checkout of the plane.
Congratulations, pal. You're going to love flying the Bonanza, especially the A36.
Yeah, I'm really excited about it.
Your airplane is a little unique.
The tip tanks.
Precisely. Most A36 don't have them, but the manufacturer will supply detailed information on their installation and operation.
Charlie, I thought I knew everything about fuel. Never put the wrong stuff in the tanks, but these tip tanks are complicating the issue.
Flying with tip tanks isn't that difficult. It just takes a little more planning to cover such things as gross weight and fuel management. Here, let me give you an example. Let's say you load your family and a lot of baggage onto your plane. Now, your useful load limitation may not accommodate all the extra fuel in the tip tanks. But on the other hand, if you're flying alone, there's no problem filling all the tanks.
Simple matter of weight and balance. It's not a problem, Charlie. It's not a problem.
Well, good. But that's just the beginning. You've also got to consider the rate at which the transfer pumps move the fuel from the tip tanks to the main tanks.
What difference could that possibly make?
Well, in your A36, the engine burns about 16 gallons an hour, but the tip tanks pump only 15 gallons an hour.
So I transfer fuel as soon as possible, right?
Well, yes and no. Your engine's fuel injected, and that means there's another fuel line that returns unused fuel to the tanks. If you start pumping the gas from the tips too early, there'll be an overflow at the main tanks, and you'll have less fuel than you planned on. I recommend running an hour on each main tank and then transfer fuel from both auxiliary tanks at the same time. That will accomplish two things. First, you'll maintain balance on the airplane. Second, if you're setting out on a maximum range trip, along over water leg, for example, you'll know if you have a fuel transfer problem and plenty of time to turn back to your point of origin. Let me tell you about a game that I've played with myself for years. A major part of flying your plane safely is knowing its habits. Habits such as how much fuel will burn in a given situation. Sure, you can keep track of fuel use on your kneeboard, but it's also helpful to track and know mentally. So the game goes like this. If I'm flying from an airport, having just been topped off, I'll try to guess how much fuel I'm down when I land. When line service finishes and I get the receipt, I compare what I've actually used to my estimate.
Oh, okay.
If I'm off more than a gallon or two, I go back and do the math. Were there headwinds? Was I flying at correct lane? Things like that. Of course, when I'm new to an airplane, I might be off at first, but after a few trips, I can mentally compute my fuel use to within a gallon.
That's pretty good.
And I do it for every trip. Come on, let's get aboard. Okay, Ed, we're going to do a checkout. And first of all, let's review the systems that have to do with fuel. You already know most of the basics, but this is a refresher course.
Lead on, Professor.
This switches the fuel draw from one main tank to the other, controlling which tank is operative. Also, for the main tanks, each has its own fuel gauge. High-wing planes like a Cessna rely mostly on gravity feed. There might be an electric boost in there somewhere, but mostly gravity pulls the fuel toward the engine. In a low-wing airplane like a Piper or Beechcraft, there will be an engine-driven mechanical fuel pump, in addition to at least one electric boost pump. The boost pump may be used for takeoff, landing, priming, and emergencies, depending upon the manufacturer's recommendation. Just make sure you know where everything is before you fly a new airplane. This airplane is an earlier Bonanza with a single-position electric fuel pump. On later models, there are 3 positions: off, low, and high boost. Now, the high position on the electric fuel pump is used to prime the engine for starting. The low position is used at altitude and for in-flight restarts. It's also useful for hot starts.
Great. Now the tip tanks.
Not quite yet. First, let's discuss the altitude-compensating engine-driven fuel pump used after 1984. This pump will compensate automatically for altitude changes. You don't have to reset the mixture unless you're going to increase power beyond 75%. An example of this would be to prepare for a go-around before landing. Now, moving right along, this gauge shows how much fuel is in the tank you selected.
Great, so I can rely on the fuel gauges, right?
Not true. I don't care what kind of plane you've got, the fuel gauges can often be wrong.
Ought to be a law.
Well, there is. But the gauges are only required to read correctly at empty. Always check the fuel supply for yourself firsthand. Before you take off, use the tabs or a measuring stick in the main tanks, and you can check what's in the tips by looking into the tanks. The fuel flow from the main fuel tanks is controlled by the red lever on the floor behind the pilot's left leg. It has 3 positions: right main tank, left main tank, and off. To transfer fuel from the tip tanks, you bring these switches up, hold them for a few seconds, then if the lights stay on, you're transferring fuel. Oh, here's an important point. No matter how much fuel you think you have, remember there's a difference between gross fuel and usable fuel.
My personal choice would be the usable.
Obviously. Gross fuel is all the fuel on board, but some of it can be lost in the plumbing and nooks and crannies of the tanks. The fuel that you can't burn is the unusable fuel.
Any idea what percentage of the fuel is usable?
On this particular Beechcraft with tip tanks, 98% is usable fuel.
This is all pretty complicated. You think I'd better take an instructor on my trip to Amarillo?
No, but you had better remember to recalculate your weight and fuel supply. Now, let's go do our pre-flight check.
On a pre-flight, always pay particular attention to the fuel tank sumps.
Sump being the fuel tank catch-all.
Right. It's the last point you can catch the water and residue that can accumulate in the tanks.
Right.
After you take off, it's too late. And remember, when you're sampling the sumps, always check the color of the fuel closely. Then you'll know if they've poured the wrong type of fuel into your tank.
Never poured the wrong stuff in yet.
Well, it's never intentional, but it can happen. And right here on the opening to the gas tank is the octane rating for this Bonanza.
Right. I got a question for you. What if I find myself at some obscure airport, low on gas, and they don't have the octane rating that's recommended for the plane?
Important rule to remember. You can always go up in octane, but never down. Your engine requires 100 low lead, but you could use 100 in a pinch.
Well, what if that smaller airport doesn't carry the higher octane? Can I then go down?
And my boy, if you go down, you may not go up. I suggest you grab a bus. And by the way, don't ever try to use jet fuel in your plane. It will do severe damage and probably cause engine failure.
Really think that small airport's going to carry jet fuel?
You never know what you're going to find at these airports. Come on, let's take this beauty up for an intro flight.
Let's do it.
You've seen what planning a flight from the fuel perspective is all about. Now let's summarize. We've learned that the fuel gauges used in private aircraft are only required to read accurately at the empty position. The interpolation of those instruments in the middle of the scale is not recommended, as it will vary from aircraft to aircraft. No 2 airplanes are alike. Get to know the one you're going to be flying, how much fuel it holds, what attitude it needs to be in to be filled completely, and what it burns. Do your math. With the portable GPS devices that we have today, it is not hard to calculate your distance remaining and then figure your fuel. If you have the money, there are fuel flow devices that attach to the GPS and will give you all the fuel parameters off a readout in the panel. Always land with a minimum of an hour of fuel remaining in the tanks. And if you need fuel, get it while you're at least an hour or 100 miles out. Statistics show that pilots who plan to refuel closer to their destination will quite often try to go the distance, resulting in off-airport landings and accidents. Lean properly. On all piston aircraft, this practice will increase the range significantly, and if you are counting pennies, you'll save money. Many pilots run slightly rich during climb out and then lean after they level off at their cruising altitude. You would do this by using the EGT indication and at peak temperature enrich the mixture by about 100 degrees. Be conservative with fuel usage and estimations if you aren't familiar with a plane, especially rental airplanes. And finally, the most important thing about fuel is this. Fuel is not as much pounds or gallons as it is time. How much time you have to fly depends on how much fuel you have. How far you can go depends on ground speed. Too many pilots fail to amend forecast-based range calculations with information from actual flight conditions. Let me leave you with this old adage. The three things that are useless to pilots are runway behind them, altitude above them, and fuel in the truck. We're confident Ed has learned his lessons about fuel, and we wish him a safe flight to Texas, just as we wish you safe flying, no matter what your destination.